Hi everyone, hope you're doing well. This is a video for today's lesson, day 86, and it's composition of transformations. Basically, it's a review of all the transformations that we know how to do, but they're on the graph and they're combined. So nothing really new I'm teaching because you know how to do all of them already. They're just going to be combined. So these are compositions. All right, here we go. So it says when two or more transformations are combined to form a new transformation, the result, so it's two or more, is a composition of transformations. In a composition, the first transformation produces an image upon which the second transformation is then performed. So first example, this one's actually kind of already done for us. So example, given triangle A, B, and C, so this is your original triangle right here. It said it's then reflected in the x-axis. So reflected in the x-axis. Now reflect over the x, you change the y. Okay, and then from here, you took this second one, so you took the image and you did something to that. So you took the image and you translated it 5 units to the left and 2 units down. So each point, 5 to the left, 1, 2, 3, 4, 5, and then 2 down. So this right here is your double prime, and that is a composition. So it's the original, you do one type of transformation to it, you take that image and do another type of transformation to that, and you produce, I guess, like kind of like a third image. So triangle ABC is reflection, so we already talked about that from above. This is reflection. And then triangle A prime, A double prime, B double prime, C double prime is a translation of T. Remember this, the negative means left 5. This is just in symbol form. And the negative here, that means down 2. And then you get these. So now what we're going to be doing also is we're going to be bringing up the words congruent or similar. Okay, so congruent is the same shape and size, and then similar is the same shape and different size. So if you notice, from beginning to end, okay, from the beginning to the end, they're the same shape and the same size. So these would be congruent. Congruent shapes again, same shape and same size. It has to be both of them, has to satisfy both of them. All right, so in 8th grade, we used some other words besides similar and congruent. That's more, I guess, like 7th grade vocabulary. So we step it up a little bit. Translations, reflections, and rotations. Those that do not change the size, okay, those that are congruent. In 8th grade, we call them rigid. So translation, reflection, rotation. None of them change size when you actually do them. So that's called a rigid. Again, that's because they do not change the size or shape. So anything that you know as congruent, we can also call rigid in 8th grade. Okay, let's see, characters, length of the line segments, angle measures, parallel lines, everything is the same. That's why it is congruent, and that's why they're called rigid. All right, and then when you have similar, okay, similar means that it's the same exact shape, but not the same exact size. That's similar. We call that non-rigid. So rigid is congruent, non-rigid is similar. So there's only one type of transformation that is non-rigid. That's going to be your dilation. So those are the only ones that change the size, but again, that shape is not changing. So dilations produce non-rigid. Only the line segments change, the angle measures remain the same. Okay, so congruent means same shape and size. In 8th grade, we call that rigid. Similar means same shape, different size. In 8th grade, we call that non-rigid. Translations, reflections, rotation are rigid. Dilations are non-rigid. All right, so now that we know that vocab, we're going to apply that vocab to our questions as we do them. So here we go. So given triangle A, so you have your original triangle right here. Draw the image formed by dilation with a scale factor. So that's going to be our second one. Dilation with a scale factor of 1/3 to form your primes. And then we're going to translate the primes, translates 1 to the right and 4 down. Okay, so you have your original, you have your image, which is going to be dilation. Remember, we learned dilation the other day meant to multiply. So multiply by 1/3. And then we're going to take these and we're just going to slide them 1 to the right and 4 down. And then we're going to figure out if it's congruent or similar and all that good stuff. So if you notice on the bottom, I also have the coordinates that we're going to fill in. I guess we could do that when we are done. Okay, so let's start with the original. So -9, -3. Oops, you can't see this. Let me zoom out a little bit. -9, -3 is point A. Then we're going to do -3, 3, and 0, 0. So -3, 3 is up here. And then 0, 0 is right here. Make sure you have the capital letter on those. Has to be capital letter. All right, so that's that beginning one. That's our original. And let's put those coordinates in. So those were given to us. So -9, -3. And then we have -3, 3. And then we have 0, 0. All right, so now let's do our second one. So our second one is our dilation. Again, that means to multiply. So you're going to multiply every single one of these coordinates by 1/3. I already know that it's going to be a smaller, so a reduction, because you're multiplying by something less than 1. So 1/3 is what we're going to multiply by. So these will be under a dilation of 1/3. So -9 times 1/3 is -3. Just in case you forget, you can do this on the calculator. -9 ABC. Nope, try again. -9 times 1 ABC3. -9 times 1 ABC3, and that gets you -3. And then -3 times 1/3 is -1. -3 times 1/3, we just did that as -1. 3 times 1/3 is +1, and these are going to stay 0. So this was your original. Okay, we use that original to get our dilation, which we're going to plot right now. So -3 and -1, that's A prime, -1, -1, nope, -1, +1, -1, +1, sorry, is B prime, and then 0, 0 stays. Just make sure you have a letter there to represent it. Okay, so you notice it's the same exact shape. Okay, same exact shape. It's just a different size, and it should be a different size because you did dilation. Dilation is the only one that changes its size. Okay, so now here comes a composition now. Here comes a third thing that we want to do. So we're going to take the orange one. Okay, this is the orange one right here. That's our orange one. And we want to translate that 1 to the right and 4 down. Okay, so take your orange, your second triangle, 1 to the right and 4 down. So A prime, we're going to go 1 to the right and 4 down. And that's going to be A double prime. Now we're going to go to B. 1 to the right and 4 down. That's going to be double prime. And then C, 1 to the right, 4 down, and that is C double prime. And that is your translation. And now let's get those coordinates right now. So these coordinates were translated 1 to the right and 4 down. Okay, 1 to the right is +1 and down 4 is -4. So let's see. A double prime is -2, -5. B double prime is 0, -3. And then C double prime is 1, -4. Okay, so now the graphing is done. The coordinates are done. And now what we want to do is go back and answer this question, congruent or similar. So from the end one, the last one, to the beginning one. So the beginning was your yellow. The end was your pink. what's the first thing you notice? The most obvious thing is that they're not the same size. So not the same size means similar. And in 8th grade, we can also refer to that as non-rigid. Okay, we can refer to that as non-rigid. All right, hopefully that example was not too bad. Let's move on to the next one. So same scenario, or same kind of question, where we have an original, then we're going to do one type of transformation, and then a second. So let's start with our original. And we have 5, 4, 1, 4, and 3, 0. So here we go. So 5, 4 is C, 1, 4 is A, and 3, 0 is T. Okay, and that is your original. And now we're going to do our next transformation. So we're going to take that original and we're going to reflect it in the y-axis. Okay, we're going to reflect it in the y-axis. So remember, you can do the, same spacing. I'll show you that. But also you can remember the rule. So reflect over the y, you change the sign of the x coordinates. So you reflect over the y, you change the x. So basically you're just changing the sign of these things right here, of those x coordinates. So -5, 4, -1, 4, and -3, 0. Okay, I'll also show you how you could do it the counting way. So this is our reflecting line right here, right? This orange line, the y-axis. This is the halfway points. So if A is 1 to the right, A prime has to be 1 to the left. And that's -1, 4. Okay, A prime, -1, 4. Oh, I should have went in order. That would have made more sense. Sorry. All right, C is 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the left. And that should be -5, 4, -5, 4. So our A again was 1 to the right, 1 to the left. Now let's do T. 1, 2, 3 to the right. That means I go back to reflecting line, 1, 2, 3 to the left, and that gets T prime. And that's -3, 0. So I showed you how to reflect over the y-axis, or reminded you, by not only doing the rule way, but also by doing the counting way. All right, so again, here's your composition, because now we're doing a third one. And what's our last one? Let's see. Oh, that same thing again, same thing you learned yesterday. Rotation 90 degrees counterclockwise. Notice it's always going to say about the origin. That's what we do here. Okay. So 90 degrees, it's going to be on its side. And counter is to the left. And what is your rule? Remember, rotation of 90, you have to switch the order. So X and Y. Counter is to the left, so you change the one on the left. Okay, so again, you're changing these ones right here. This becomes this, and then the second one becomes the third one. So if we swap the order, change the one on the left. Swap the order, change the one on the left. Swap the order, well, I can't change that. Change the one on the left. Okay, so now let's do this the turning way. Make sure you're not looking at the original. You're looking at this second one. You're looking at the image. And we're going to go to the left 90 degrees. Okay, so let's see. So I'm going to go to C prime. And now this is really C double prime. And it's left and down. So -4, -5. That's what we had, -4, -5. Left and down. So it's -4, -1. -4, -1. And then 0, -3. 0, -3. So whichever way you want to do that, it's up to you. Either the turning way, or you can do it the rule way. It's completely up to you. Okay, so there's your composition. There's your third one. And now let's answer that question. So from the beginning to the end, did the size change at all? No. Did the shape change at all? No. So that's going to be congruent. and congruent in 8th grade is referred to as rigid. And actually, also 10th grade too. You're going to be doing this a lot in 10th grade as well. Okay, hopefully this is not too bad for you. We got one more to go. Right, last one. Again, we start the same. We have that original. So we have -5, -1. That's Q. -3, +3. That's R. And 0, -1 is S. Okay, and there is your original. All right, next one. Now we're going to do a dilation with a scale factor of 2, and that's going to go right here. So all of these, it's going to be D2. So dilation, we learned the other day, is to multiply. So multiply all the coordinates by a scale factor of 2. Multiply all of these coordinates by 2. Okay, don't forget your parentheses. Remember, they're not coordinates unless they have parentheses around them. So multiplying this by 2 gets me -10, -2, -6, 6, and 0, -2. So now we're going to graph that. -10, -2 is Q prime. -6, +6 is R prime. And 0, -2 is S prime. You do notice that the size changes. That should kind of already, you know, in your mind, you'll be thinking about what vocabulary word you're going to use for that final question. Okay, remember, dilation is the only one that changes size. And this one is an enlargement because you multiply by a number bigger than 1. All right, and what's our last one? Okay, so we're going to take our second one and we're going to translate it. So our second one goes to our third one. Remember, X is positive to the right. So this is 1 unit right. Y is positive up here on the top, so up. So this means 4 units up, okay? So that, I think, is the easiest way. The other way to get these coordinates is by doing some math, and I'll show you that when I'm done graphing. So again, make sure you take this orange one. It's very, very important. You're going to go 1 to the right, and then you're going to go up 4. Remember, don't put that dot until you do both moves. And then you're going to go 1 to the right, and you're going to go 4 up. Oh, right to the top of the paper. And then S prime, 1 to the right, and 4 up, and that's S double prime. Okay. So let's get those coordinates of this last one. So Q double prime is -9 and 2. R double prime looks like it's -5 and 10. And then S double prime looks like it's 1 and 2. So I said there was another way to get these numbers, and that's by just doing the math. So -10, you take these X values and plug it in here. -10 plus 1 is -9. -6 plus 1 is -5. 0 plus 1 is 1. And then add 4 here. So -2 plus 4 is 2. 6 plus 4 is 10. -2 plus 4 is 2. All right, so now that everything's graphed, now answer your last question. So automatically, dilation, different size, is the only one with a different size. That means these are going to be similar. And in 8th grade, we call that non-rigid. All right, hopefully this video helped you for transformations. And you have one question for homework tonight, number 86, homework number 86. Make sure you post this on Google. So for tonight's homework, you are going to do, first of all, you want to get the coordinates of this original. Okay, so you want to plug those in. And then you want to take that original and reflect it over the x-axis. Reflect it over the x, remember you changed the y. you change the y, and that's going to go right here, those numbers. And then for the final thing, you're going to take this one. You're going to take the image, and you're going to do a translation. Okay. And for the translation, this means +4 is going to be 1 to the right. And this -1 here, 4 to the right. And then this -1 over here means down 1. So you're going to take everything from here and you're going to move it 4 to the right and then down 1, and that's how you're going to get these coordinates. So make sure you graph those other two as well. All right, hopefully that helps. Have a great day.